All right. So this video is going to be about the purposes of bonding, comparing and contrasting covalent and ionic, so two of the big bonds that we talk about, ranking them strongest to weakest, and then we're going to look at the steps that are involved in forming an ionic bond. So the purpose for bonding is because atoms want to be stable, and the easiest way for them to be stable is for them to have 8 electrons in their outer, 8 electrons in outer shell, and we call that, or outer orbit, whatever you want to call it, we call that the octet rule. And so we'll talk about that more when we get to this ion down here in the corner. But so that's really the purpose of bonding, is to try to either get some electrons to fill that outer shell or lose some electrons and go down a shell. All right, so there are there's a bunch of different types of bonds, but there are two main ones that we talk about in AP Bio, and that is covalent and ionic. We also talk a lot about hydrogen. We'll talk about that up here, but for right now, we're just looking at these two. A couple of things about covalent. Covalent is going to be two nonmetals coming together, and when they come together, we tend to call them a molecule. Whereas ionic is going to be a metal plus a nonmetal, and we tend to call those compounds. So if you hear somebody talk about a molecule, they're probably talking about a covalently bonded molecule. If you hear them talk about a compound, it's probably something that has ions that are bonded together. Ionic have a very orderly or lattice structure, whereas covalent, they have more of a molecular, so it's not as orderly, not as structured, I guess is the right way to put it, as the ionic. Covalent, you can find them as a solid, liquid, or gas, so they don't really have a preference, whereas ionic tend to be solids. Okay. Covalent, they are not very soluble. You can try, and sometimes you can get them to dissolve some, but they're just not. And ionic are highly soluble. Highly soluble. Covalent has a low melting point. If you think about sugar, if you put sugar in a frying pan and turn the stove on, it'll make caramel. Eventually, there's a little more to it. You got to add milk and stuff, but it will actually melt. It will caramelize. Whereas salt, if you put salt in a frying pan and turn it on, it's going to stay salt. It's not going to do anything. And so it has a higher melting point because it's an ionically bonded molecule or compound. Covalent is not conductive, so not conductive, whereas ionic is electrically, can't talk, conductive when it is in solution. So if you take salt and you dissolve it in water, it will then, you'll be able to send electrical currents through that. So in solution. And the last thing is sometimes covalent are odorous. They can be stinky, like hydrogen sulfide, smells like boiled eggs. So that's some ways that they are different. Really no way that I can help you remember that. It's just one of those things you have to kind of memorize. Some ways that they're similar is they are a connection or a joining of two atoms, not a permanent joining, but they are a joining of two atoms. They do involve electrons. Covalent, you could say they share electrons. Ionic, they give and take. That would be another contrast. All right, so strongest to weakest. Now this is where it gets a little iffy. The strongest bond on Earth is your diamond. So diamonds are covalently bonded molecules. However, if you took diamond out of the picture and you just looked at the rest of the covalent and the ionic tend to be stronger. So I'm going to say that ionic are the strongest bonds because as a group, as a whole, they are. It's just so happens that the strongest bond is covalent. But as a whole, as a group, ionic. So we're going to say they're stronger. Covalent would then be the next. And then, hydrogen would be last. Now, there are other types of bonds. Those are the three we talk about in AP Bio, so those are the three we're going to stick with. If you talk about diamonds, you could argue covalent being stronger, but for most questions, they're going to assume that ionic is stronger. All right, and then the last thing is the steps that occur when an ion is formed or ionic bond is formed. So here we have two molecules. We have a metal, beryllium, and a nonmetal, oxygen. Beryllium has a atomic number of 4, so it has 4 protons and 4 electrons. 2 electrons on the lower level and 2 on the outer. Oxygen has an atomic number of 8 protons and therefore 8 electrons. So 2 electrons on the lower level, 6 on the outer. These make a really good pair because electrons, they both want full outer energy levels. And for atoms, the inner level, the first orbital, can hold up to 2. So if it's got 2, it's full. The second level can hold 8. So if it's 8, it's full. And then any outer level, like the third level can hold 18, but if it's the outer level, it only wants 8. So the outer level is always going to have 8. So beryllium is like, well, I really could use 6 more electrons, or I could give up these 2 and drop down to just having 1 energy level and it would be full. Oxygen is over here thinking, wow, I've got 6 in my outer. I really need 2 more. Or I could get rid of 6, but getting rid of 6 is going to be really hard. Gaining 2 is going to be a lot easier. So what happens is beryllium and oxygen make a deal, and beryllium says, sure, you can have my electrons. And so those 2 electrons from beryllium, their outer energy level, go over to oxygen, and that's going to give oxygen 8 in its outer level, so oxygen's going to be happy. But it's also, because these are negatively charged, it's going to give oxygen a charge of -2. Because it just took on 2 more negative charges, 1 for each electron. Beryllium, on the other hand, has just lost 2 electrons. So when it gave up those 2 electrons, it became positively charged, +2 because it lost 2 electrons. It's happy though because it's down to 1 energy level with just 2, so that energy level's full. Oxygen is happy because now it has 8 in its outer energy level, and so its outer energy level is full. So they're both happy. But what we see now is opposites attract. So when you have these 2 different charges, they're going to be attracted to each other. And so you're going to see this bond form between oxygen and beryllium because of the opposite charges. So your like charges will repel, so negatives are going to push away from each other, but when you have a positive and negative, they're going to be attracted to each other. And so the steps, I would say, in the formation of an ionic bond would be, first, the movement of the electrons, so these 2 going over to oxygen. That then creates ions, and those ions are then attracted to each other to form that ionic bond. So just a couple of steps, and we don't really think of them as steps, but that's kind of what's going on. I hope that helps. If you have any questions about any of this, about why they bond, comparing and contrasting covalent and ionic bonds, ranking them, make sure you can rank them strongest to weakest, but also weakest to strongest, and make sure you read the question carefully if you have a question like that, so you make sure you're doing it in the right direction. Or if you have any more questions about ionic bonds and how they form, just let me know.